Good morning. This is Rhonda Edwards from the VMware Open Source Program Office, and I'm here with Tim Pepper, who's a senior software engineer. He's going to be talking to us today about Kubernetes patch releases and triaging incoming pull requests. Welcome, Tim.
Hi. So while I'm going to give sort of an example of some things that we do in the Kubernetes project, this is hopefully a kind of generic learning as well that others could apply to their open source projects to think about how they triage. It's a pretty common pattern where you've got things coming in from your community and you need to weigh against some set of criteria whether you're going to accept the thing in. So I'll talk a little bit specifically about how we do that for Kubernetes. First, a tiny bit of background. The Kubernetes project currently releases a major release 4 times a year, and then each of those for 9 months following that gets patch release support. And we have a team of folks who manage that patch release flow, and that is called the patch release team. And what happens typically is a change will get made on the main trunk master branch in Git or on GitHub for the Kubernetes project, and then the responsible owners, we call them, for that area of code will suggest, hey, this is the type of bug fix that probably should be cherry picked back to our support branches. So I'm going to go through sort of a triage of some of those things that have been proposed for cherry picks back to the 118 branch. And we just released 118.2 yesterday, and we're starting to now triage incoming things that would flow into 1.18.3. So one of the ways that we do this, since we have a team, you could imagine that all of this stuff is just artifacts on GitHub, and you have everything you'd need there for collaboration. But as a team of us are looking at the state of these things and trying to figure out whether they go in, sometimes it's hard to track all of that just by what's in GitHub itself. And we use a spreadsheet then to track what's going on. And what you're looking at here is basically our tracking sheet for 1.18. We have a set of 6 things that we are aware of that existed and carried over from yesterday's release that weren't ready to go into yesterday's, but we're still tracking those forwards. And maybe one of the things that you see here immediately in this first row is in the tracking sheet, we're tracking something that doesn't yet exist. We heard from somebody that they intend to do this thing, and we want to make sure that we pull it in, but it doesn't yet exist as a pull request. So we're waiting to see where that goes. So what we do is we compare the status or the state of our sheet against the open cherry picks against a branch. And GitHub gives us a nice view. Right now I have 8 things open, and in my sheet, I only had 6 that I was tracking. So immediately I know, like, oh, I've got some new stuff coming in probably just based on that count here. The other nice thing that GitHub gives us is this blue bar on the side for each of these pull requests. That's telling me that something has changed on that thing since I last looked at it. So for example, if I just start kind of reverse chronological order, I look at this oldest one, I go in here. So this is pull request 89.809, and on my sheet, I've got it here. Last time we triaged, it was needing what we call a LGTM. Looks good to me. And then we had some concern maybe that there might be some performance overhead change. Looking at it before, we had some concerns maybe or questions what might happen. So I'm going to go in and look at what's going on in this. It now has its LGTM label, so that's cool. And then the other thing we do on our project, we have some automation. When somebody first creates a pull request against one of our release branches, we have a robot that goes and tells some things about it. So this person, Jay Safrain Jan, opened this pull request, and our robot replied, hey, this looks like a cherry pick PR for a release branch. It's not been approved yet. Here's a link to the documentation on how to go about getting something into the release. So we try to sort of have a clear and transparent process. We tell people what they can expect around patch releases, what it takes to get a patch into one of these branches. So there's a set of criteria that are automated, and then some of them are subjective. As I scroll through this, I'm seeing we've had a variety of conversation points, and basically what our tied robot is telling us, this can't be merged yet because it's got the do not merge cherry pick not approved label. So that's really the final step. The LGTM and the approved labels come from code owners, subject matter experts who have decided, hey, this is actually an important fix for storage, in this case, for a bug. We approve it to go into the prior branches. Now, depending on the scenario, we go into different levels of detail. We look to see our tests passing. And again, our robots in GitHub are telling us a bunch of test results here. These are all green. That looks awesome. Relative to that prior question, like, do we have any performance concerns? Like, this is passing CI. That's good. I also look at some just really simple superficial things, like GitHub's telling me this is a small change. That's good. We don't like to make massive changes. This is actually a bug. We watch to make sure people aren't trying to backport features. That's something that we have a policy of not doing. And every project is going to be different on what these specific criteria are. We also look to see that there's maybe good hygiene on the Git commits, that the commits describe what they're doing. Unfortunately, in this case, this isn't the best example probably, because the commit message here is really, really short. It doesn't quite describe in detail what's going on. But oh, this one actually does a little bit more. It's speeding up unit tests and adding some observability. So it's nice to see that we're potentially going to get better performance in some tests as a result of that. We look also to see that we're not just adding code, but we're adding tests. So I look at the different files and functions. These are all core code, but here I have a change to a test. This is an interesting one from a code pattern perspective. It's going from a certain set of time constraint polling to a different one. And often that's a way of introducing a bug, so this is something to be aware of, but this is also a very small patch, and it's been reviewed by its subject matter experts, and they've chosen to accept it. So on the patch release team, we tend to be sort of something that I describe as like a worrywart or a curmudgeon. We kind of look at these things and somewhat subjectively weigh, like, is this really worrying? Has it had a quality review? And for most of these things are fairly simple, small, constrained changes, and they're coming also from something that landed on our master branch. So I can go in and look at that issue and see what the conversation there was, how people went around. Obviously, this is merge. That's one of our criteria too. We don't backport things until they've been accepted. So we try not to kind of get ahead of ourselves in that regard. And this one also is logged as fixing an issue, so I might go in and read that. And this can be a fairly slow, time-consuming process, trying to collect, like if you look at the scroll bar here, like there's many pages of history and conversation on the master branch around this issue, and then there's also many pages of the original bug report. So we try to bring out this context and somewhat objectively, somewhat subjectively decide, like, is there something worrying here? Is there anything that's been missed? Kind of like the worrier in chief kind of attitude of making sure is the last pass criteria that this thing is actually ready to merge. On this particular one, I have a couple other things that I want to look at because it's being picked both to the 118 branch and the 117 branch. And this is something that we've previously gone through and deduced. There's not a fantastic way within GitHub to recognize when you have a family of things. So this one feels like it's probably ready to merge on the 118 branch, but I want to double check that, like, somebody on the 117 cherry pick hasn't said, like, whoa, this is scary, wait a second. But it's looking like it's got basically the same status, it's all ready. So for the two of these, I've got the two picks, 89.809 on release 118 and 89.810 on release 117. These look ready to go. So what I do is I go in, and this is sort of a privileged command or ability that we have, the set of patch release team members. We can say that this is cherry pick approved. And we have automation in the background that notices that's now approved, and it removed that other label that said it was not approved. And I do that on the other one because we like to do this as a set so that we have consistency. We don't have bug fixes on the newest thing and on the oldest thing, but not somehow in the middle, because that leads to a bad user experience. So I make sure both of those go. And then our automation is going to start. It will eventually notice this event in an event-driven system, and it's going to, there we go, it just updated. It sees that these things have been approved and it starts a fresh set of testing. And we have a tool called Tide. And I can see these both now are in our Tide pool, working their way, merging into the branch. And these now, assuming they don't have any additional CI failures, test failures right now, these will flow into the 1.18.2 release and our next 1.17 release, which is 1.17. Our next one is going to be 1.17.6. And then because I have team members in various other time zones who also keep track of these things, I go in and I make sure that I update these as merging. And sometimes things get stuck. I kind of highlight this as green, like we think it's ready, but I highlight this merging for the time being as yellow, because it may fail to merge and we need to circle back. It will no longer show up in our simple GitHub query of things that have not been approved, but that doesn't mean it's merged. So as time goes by, we keep sort of rolling through and iterating on these and making sure that we're pushing things all the way through the system and kind of shepherding them through to merge. And that's the process that we do. On any given day, we may have 50 of these or 8 of these, and we try to push them through on all of our patches and make sure that our user base gets good bug fixes coming at them regularly.
So this is very interesting. A couple of things. How many of the SME or subject matter experts typically review some of that code before it gets to the patch release team?
It really varies. Some will come to us with none, and this is something we have to watch for. So it's really incumbent on us to pour through all of those different Git artifacts and decide have the right people looked at this. We do have this automation in place that uses a set of YAML files that declare who are the owners of different pieces of code, and they are required of those people to review and approve. So at least 2 people have looked at it. Sometimes a half dozen have looked at it, sometimes it's 0, and somewhere in between there. And kind of with that warrior curmudgeonly hat on, we try to then, whether it's comment on the GitHub issue or ping a few people in Slack and just say kind of like, hey, what's up? Has this gotten sufficient review? Or, hey, I'm a little worried about this in this way. Is there anything that you could tell me about? And sometimes those will generate new conversations like, oh, I hadn't thought about that, or oh, you know what, let me add a test case, let me update the pull request to have a test that covers that. There's a different little edge there that we should think about. And we try to have good patch velocity, so we don't have like 50 people must have read this and approved it, and we have like a time delay of 2 weeks or something. But we want to pragmatically ensure that there's quality there and that we've had enough of the right eyes looking at things.
Right, and so it's not incumbent on the code, the person who's contributing the code to go find those SMEs. The SMEs are sort of defined by the area of the overall piece of code as
Yep.
you're an expert in that particular given area.
Yeah. Programmatically, that's correct, but also pragmatically, a lot of those people are super busy. They're going through this sort of same flow of who's sent stuff that I need to be reviewing. And it's a good open source practice to be cognizant of this thing that you've just sort of thrown out into the ether on the internet and understand what are the merge criteria for a given project. Read its contributing documentation, understand what those criteria are, and know pragmatically that it's open source. Some of the people may be volunteers, they may be busy, but watch and see. If nothing's happened after a couple days, look around and see who should be handling the thing next, and maybe give them a gentle nudge on Slack or on whatever the shared communication platform is for the project, and say, hey, I threw this out there, just checking if there's anything else you need from me. And that way we all have a part in keeping these things moving forward together.
Gotcha. And one last question. How do people typically join a patch release team? How does that come about?
So we actually have a process. So the patch release team is a sub-project under SIG release. So I'm one of the co-chairs of SIG release for Kubernetes, and Kubernetes is organized into special interest groups, or SIGs. There's verticals like storage and networking, and there's cross-cutting things like testing and release and documentation. Each of those SIGs has its own process of bringing in and mentoring new folks. And on our SIGs page, we have a kind of a listing of how we bring people in. We've got different areas where they can shadow somebody who's an existing leader in one of these types of ways, and then sort of a progression. We call it like a contributor ladder. There's that both in the project and within an individual SIGs. There's a way of going about that. For this particular case, it's actually a fairly privileged role because things like critical vulnerabilities and security issues that are embargoed even come through. We see them early. So we want to make sure that people have a fair amount of experience and have built up and are known within the community and trusted, trustworthy before they kind of get the magical keys to the kingdom, and understand that this is a shared quality experience that we're contributing to. So it could take some time, but there's a documented pathway to that.
Oh, excellent. Okay, I was just gonna, that would be my next question is, how do we get, sort of, we talked to some of our junior software contributors and, give them that pathway so that they understand what kind of experience that they need if they aspire to, become part of this team in the future.
Yeah, so I guess probably the jumping off point I would give for anybody on Kubernetes is start with the master SIG list. If you just if you Google Kubernetes SIG list, this should be, yeah, the #1 hit you're going to get. It lists out all of these special interest groups by name. It has who are the current co-chairs for it, how to get in touch with them on Slack or a mailing list when they have meetings. You can tunnel into the link for their name and get information about the charter and the sub-projects, how they go about doing things, and try to start getting involved.
Excellent. Well, thank you very much for this, Tim. I think this has been enlightening, and I think the rest of us, surely appreciate what you do, what the team does, and your ability to share that with us today. So, thank you.
Yeah, you're welcome.